In the last video, I have discussed about the findings on this particular case, right? Identification of the root cause, and there we have seen that this hydrogen embrittlement, which is confirmed, was occurring because of two parts of the problem. One is the corrosion problem, which was primarily because of caustic gouging corrosion that we have seen, and since there was an overheating prevailing in the system, in the furnace area, particularly towards the rear water wall, and that is how the embrittlement problem, the hydrogen embrittlement failures were occurring in this particular industry. So in this particular video, I am going to share the corrective measures that we have suggested for them to take care of the issues and to avoid, or rather to prevent, these problems to further happen. Now, I told you that once the hydrogen embrittlement is confirmed, some tubes have failed because of hydrogen embrittlement. The first thing we need to check, what are the conditions of the surrounding tubes, right? Now, this was the first measure. In fact, the measures which we have suggested are having two types of measure. One which they need to take immediately to control the failure issues, and second is a long-term measure which is not possible immediately, but ultimately to remove the root cause, to finally remove the root cause, they have to implement it. Otherwise, this is going to happen maybe after some time, but it is going to happen. So in immediate measures, the first thing I suggested that to conduct the AUBT, which is basically an advanced ultrasonic test. It's called back cluster test, to identify the embrittlement cracks in the nearby vicinity tubes, right? Which they have immediately conducted, and they found quite a number of tubes affected by this, right? Which they have replaced. The second is that since it was a strong indication of a dirty boil, those copper deposits, these are creating a very strong galvanic sites in the system. So corrosion will become very imminent in this boiler. Wherever there is even a little bit of corrosion mechanism available, it is going to attack the component because of those conductive deposits. So naturally, my next suggestion was to carry out the chemical cleaning of the evaporator circuit, the acid cleaning of the evaporator circuit. This was an immediate requirement, because without that, without removing the galvanic sites, if they continue, then the corrosion is going to continue, right? In fact, they have conducted the chemical cleaning almost immediately after I came back from the job. Then the corrosion was caustic corrosion. I have identified that time and again their boiler water pH was going to the limit of 9.7, 9.8 also, since the 9.8 was the limit. So I told them to create a new limit, not to exceed 9.7, keep the boiler water pH, there is the drum water pH, to maintain below 9.6, so in the range of 9.4, 9.5, and most importantly, to have at least a 6 to 8 ppm of phosphate in their system as a chemical backup, which is basically going to act as a chemical buffer for the free caustics, right? So that was my third suggestion. Then they were keeping the CVD open, as I told you, and that is always going to make it very difficult to maintain the water chemistry, because you are adding chemical and then you are continuously removing it, right? So the chemical balance will be very difficult. So I asked them not to do that, stop the continuous blowdown practices, because they were keeping it open, at least a crack open all the time. So I asked them to stop the CVD and carry out the CVD as and when required based on the analysis. Okay. Ammonia in the steam was very important, because okay, they do not have a copper metallurgy in their condenser, but their steam is going to other plants, right? They have got various process plants, as I have shown in the last video, and there they have the copper metallurgies, right? So it is important to control the ammonia in their steam, which is going to the other process plant, and the requirement is very precise. It is less than 0.5 ppm in the steam, right? So they have to manage to control the ammonia level in their steam to less than 0.5 ppm. The next one is the close monitoring of the hot well condition, right? Condenser leakage. Because we have seen that the calcium, magnesium, all those problems have come into the system, and it clearly indicates that in one or other process condensers have caused this contamination, right? So they have to monitor the condenser leakage probability, possibility very, very thoroughly, very closely. And that is possible by first is taking the or measuring the degassed cationic conductivity of the hot well. That is one measure. And another very useful way of checking the condenser leakage possibility is by checking the microsodium analyzer, right? Microsodium as an analyzer, if you put in the system, it can identify a sodium to the extent of less than 0.02 ppb, right? That is very small detection. It is possible by this. So even a smallest condenser leakage can be identified by the microsodium analyzer. Okay, next is that since their MB outlet was coming a little odd, right? Very high, 7.5, 7.6, as I have mentioned in the last video, right? They have some problem so far as the cationic regeneration is concerned, right? I asked them to review the cationic regeneration, and because the MB outlet is coming on the higher side, so I asked them to top up the cationic resin in the cation resin in the MB, in their mixed bed exchanger, right, by 50 liter, and see the changes, whether they're getting any changes in the pH or not, which they have later on. They have corrected the ion exchange process, and they could manage to get the pH in the required level of 6.87. Now the thing is that they're having a high heat condition, and the high heat condition is increasing. The heat flux concentration in the system is increasing whenever they are trying to operate the system at a higher load. Yes, they have got 3 boilers, so the process requirement can be managed with partially operating 2 boilers, right? So I asked them to limit the boiler load to 180 TPH till at least one round of chemical cleaning is done, and those affected tubes which were found by the AUBT inspection are replaced. Till that time they have to maintain the boiler load on the lower side. Okay. Now the ramp up rate, because there was a clear indication of DNB, as I have shown in the last video case study, right? There was typically identification of film boiling in the system, and below the film boiling the corrosion mechanism is going to be prevalent. So one thing they have to correct is the startup procedure. So they have to maintain the startup ramp up rate according to the startup curve given by the OEM, right? That is one thing. And second thing is that they have to have a very thorough, very strict level control during the cold start, because at that time it is a manual control, right? And they are doing only the level control, and because of the swelling phenomena they are having a tendency of keeping the level a little low, the set point level a little low at the time of cold start. And in one of my videos on circulation I have explained what harm that can lead to, right? So they have to have a dedicated person for the level control during the cold start. That is another suggestions to them. FG on the upper elevation, because I have found that the upper elevation furnace is showing a little higher temperature. The temperature spray is also on the higher side, right? And when you are having a gaseous fuel, operating on the upper elevation burner, because they have got two elevation burners, then it will have a more tendency to go towards the upper part of the furnace faster, right? So instead of that, if they can possibly manage to fire the FG on the lower part elevation of the burner, then it is going to have a better control, because in addition to the rear water wall issues, I have already identified that the superheaters are also under threat overheating, because high temperature, indication of flame towards the upper part of the furnace from the peepholes, these are all indicating that the combustion is taking place a little lopsided towards the upper side. Okay, uh, this is one suggestion I have made them to control the flame length, because I have already found that they have a PA damper, and this PA damper can be operated, because one of the boiler was under shutdown when I visited, and I went inside and I saw that okay, if we close the PA damper clockwise, right, so every one turn, clockwise turn by 2 pitches, right, around 10% of the holes are getting blocked. So the PA part which is getting distributed from the wind box, that is going to be reduced, because if the PA is higher, then there is a tendency that the secondary air which comes from the periphery of the burner, right, it cannot catch the fuel. The PA takes it away faster, right, and that is one of the reasons that can lead to a longer flame, in addition to the atomization issue which I have discussed. So I have suggested that okay, you close it by 2 turn, so by 10% margin, and see what is the condition of the flame, right? What is the condition of the flame? If they can find that the flame condition has improved, then after they reach the final load, they can close it by another 10%, right, and see what is the flame condition. So that is one suggestion. And the feedback which I have received after from them, that they could find that considerable difference has been made when they have reduced the primary air, and they have done it further by 10% and could manage to reduce the flame length by a reasonable magnitude. Okay, now furnace temperature is a condition which is going beyond their control. Why? Because as I told you, the boiler was under design. If the boiler was under design and they are trying to increase the load, then the furnace is going to be heat up naturally, right? So I asked them that, unless, because they have to assess the total the design capability of that boiler, right, by some test, some trial, they will have to do it, and they will have to find out okay, what is the load the boiler is capable of handling without disturbing the tube metal temperature and the flame condition and the furnace condition. So till that time, one logical suggestion is to keep the furnace cool. So I asked them to keep the furnace diluted by a little higher excess air, because at time like this you cannot think of performance. Then you have to ensure the reliability first out, because unless the boiler is available to you, what is the meaning of performance? So I asked them to dilute the furnace by keeping a little excess air. So I asked them to increase the oxygen percentage by 1%, right, till the assessment is being done that okay, to what capacity it can withstand, right? What is the furnace capacity? Cleaning the IFO burner, cleaning the oil pump suction filters, because these are all the factors which are responsible for the flame pattern, and they were not doing the right practice. So the burner cleaning, the filter cleaning at least once in a week is always a good practice, and that I have suggested them to maintain a proper flame health. While draining the water, because they were not having a day tank, so they were draining from the main storage tank, which was not being cleaned. And okay, cleaning is immediately not possible, but draining has to be done properly. So draining is to be done by keeping the temperature by ensuring that the temperature is at least 80 degree. Because you see, when the temperature is in the range of around 80 to 90, the specific gravity of water and oil differs even higher, right? So all the water part will go below, and it will be easier for them to remove the water. Another thing is the way they are doing it. So what I suggested them that, okay, you open the valve, open the drain valve and see the water coming out. The moment the oil starts coming out, the normal tendency is to stop the valve and understand, okay, all the water is drained. But do not do that. Basically wait for a while, then again open it, right? So basically throttle the valve couple of times and see whether further water is coming out or not, because in my experience that way later on more water is likely to come out of the system. I have experienced it myself in couple of storage tanks, right? So just close it and then open it, and do it for at least 2 to 3 times to ensure that the water is getting removed properly. Okay, now these were the short-term measure or immediate measure which they will have to do if they want to continue with the operation without interruption. Now, but to actually remove the root cause, if to attack the root cause, then they will have to do certain things, and most important thing is that they will have to stop the contamination from coming from the return condensate, because as I told you, that is the primary root cause, because that has created the source of corrosion in the system, and which later on led to the hydrogen embrittlement issues. So all this return condensate from various process plant, as I have shown, is coming back to their condensate storage tank. So before it comes to their condensate storage tank, one final defense should be there. So one, activated carbon filter, because it's a petrochemical plant, so there can be hydrocarbon contamination is possible. So one ACF followed by one condensate polishing unit will be the final defense. But again, if you want the condensate polishing unit to work, then the temperature is another thing which is important. If the temperature, return condensate temperature is increasing, if more than 50 degrees centigrade, then you have to think of some membrane solutions, right? So that is something they will have to consider in long term to actually stop this problem. And till that is being implemented, till the final defense is being implemented, you have to assume that the contaminations are going to come from the systems. And if that is happening, then there would be, the boiler is going to get dirty and the corrosion sites are going to be created. So time and again they will have to look for such deposits, right, and go for chemical cleaning. In fact, interestingly, I will share this, that when I saw their OEM guideline, in their OEM guideline they have suggested that go for acid cleaning every 3 years, which is something very odd. I have never seen it anywhere else, right? But at least in their case, they will have to keep it under monitoring, and whenever they find that yes, some deposit indications are coming in the system, they will have to again go for acid cleaning, otherwise the same thing is going to repeat it, right? And of course they have to carry out the combustion tuning, because it has got two phases, as I told you. One is the corrosion part, another is the overheating part. And for overheating part, yeah, temporarily I asked them to reduce the primary air and control the flame length, another thing. But the final tuning of the combustion, keeping the performance in mind, they will have to conduct, right? So that is another very important part. Storage tank which they have not cleaned since commissioning, and lot of sludges are getting accumulated, and it is a big job, so that's why it's a long-term measure. But at one point of time they will have to do it, right? In fact, after 3-4 months after this this assignment was over, right, I got the feedback that yes, they have gone for the one of the storage tank cleaning, because they had 2 tanks. They have to carry out the hydro test of the steam coils which is heating the storage tank, because the source of water can be from the leakage of these coils also, because HFO is very corrosive, and the steam coils, which is basically inside the tank, right, if they starts leaking and if they do not conduct the hydro test and ensure that these leakages are not there, then the water can come from the heating activity itself. So they will have to go for a hydro testing and maintenance of the steam coils. And finally, they have to carry out, because as I shared, that I have seen the indication of the superheaters are getting affected, right? And of course, it has not yet failed, but uh, that might also start failing in due course of time because of continuous overheating, right? So what is the creep condition? What is the creep health of it? So to understand that, they have to conduct an in situ metallographic survey, right? So taking the replication of the component which are basically getting overheated, and to assess the creep damage, that is one thing. And since they are a plant who cannot operate without the boiler, right, and if suddenly the superheater starts failing, so they should have a proper, uh, the tube should, inventory should be there, right? And in their case, unless they make some critical inventory spares, right, they denote something as critical inventory spares, they don't act very far. So I ask them to maintain this water wall tubes as well as the superheater tubes as critical spares, right? So these are the basically the corrective measures which I have offered. I'm going to conclude this session here because that was all the corrective measures I have suggested. I would invite you to put your comments in the comment section if you have any specific thing in your mind that you thought that okay, this could be also done. I would welcome those suggestions, and of course a comment is going to initiate a discussion which can lead to further improvement. Both in both cases mutual improvement can be achieved, right? So thank you and bye bye.